Assalamualaikum and good morning. My name is Lutfi Hakim bin Abdul Hadi. I'm the group leader of this Tinker. Okay, today we will present about the final design of our product.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group Tinker. Today we will conduct a final presentation for IPD1. The title given for us is Flour Sieve with Dryer. This is our organization chart. For project engineer is Lutfi Hakim bin Abdul Hadi. Muhammad Shamsul bin Awar assigned as production engineer. Izzuali bin Ibrahim as a quality engineer. Muhammad Zakiuddin bin Azizan assigned as design engineer. And the last one is Muhammad Khairul Azhan bin Muhammad Safian assigned as sales engineer. The main objective for this project are: the first one is to produce the innovative flour sieve for hotels kitchen. Next, to ensure the quality of flour remain, and to install and apply the mechanical system into existing product. Moreover, to enhance users to be more efficient, and the last one is to help users produce good products. Now we move to the problem statement. I will make it short. The main problem is cannot sieve in large amount. The current machine is difficult to clean and dry, and it uses a lot of human energy and need longer time to sieve. Now we move to Gantt chart. For week 1 to week 4, we were assigned to come up with mission statement. For week 5 to week 8, we must do a conceptual design. For week 9 to week 13, we assigned to do mechanical design analysis. For week 10 to week 14, we must come up with prototype, digital analytical prototype. And we must do the final report of project, final presentation and compilation of coursework in week 14. We will discuss about data analysis. This data gathered from the site visiting survey. The most important customer needs are: first one is dry and sieve in large quantity in one time. The customer also want it is fast sieve, less human energy use, and low cost maintenance. Now we will discuss about gap analysis. There are 5 main highlighted important in this analysis, which is price, dimension and weight, material use, base design, and functionality. For the price, we will make our product affordable. For the dimension and weight, we will try to make it medium in size so it is suitable for all kind of space. Material used for our product is stainless steel to ensure our quality product. For the base, we make it stable, so we put the anti-slip under it. For the functionality, is the important to make our customer confident to buy it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakiuddin bin Azizan. I will continue this presentations under topic conceptual designs. Okay, for the first one is for me is machine element design. Okay, what is machine element? Machine element is a basic mechanical parts of machines. For example, here I put gears, bearings, screw, and etc. So usually the elements of a product consist of 2 basic types, which was structural components and mechanism. So for example of structural components of our product were frames, screws, handle, and holder in the both sides. So here we use a motor to run our flour sieve machines as the mechanism. And then next, in our product, screw is the one of the most important element in order to give more strength. So here is the design for the screw that we use. It is a fully thread, so the nominal major diameter is 25 mm. For the tensile stress area is 353 mm square, and the ultimate stress is 540 megapascal. For the factor of safety that we get from the analysis is 15. Here we do a calculation to get a force that the screw can sustain. So we use a FOS formula, factor of safety formula, which is ultimate stress will divide with allowable stress. So for the factor of safety is 15 and the ultimate stress is 540, and then we can get the allowable stress, which is 36 megapascal. So allowable stress will times to the tensile stress area to get the force, which is 12,708 Newton. So the value is more than enough for the screw in order to sustain and give strength to our machines. Okay, here I put the image of the screw that we use in our machine. Okay, and then next for the three options of conceptual designs. Okay, actually we are able to come up with several designs. So here we put the best three designs. For the first one, this is the first design. The design was complete with the heater and the vibrating treadmill in the middle of the machines as the mechanism. And then to the next one is the second design. So this is the view of the machines. So the machines come up with the heater coil and the vibrating swivel as the mechanism. And then go to the third one. This is the view of the third design. So the third design use shaft and also vibrating sieve with a motor to run these machines. Okay, we have made discussions to determine the best design that we want to use. So we decided to come up with this design. So the second design. So because the design has the highest score among the others, especially in terms of amount of the floor that can sieve, the available of heater, material use, and it is easy to use. Okay, I think that's all from my part. I will pass the presentations to my friends. Thank you.
Mechanical design and analysis. The specification of the product. First, dry and sieve in large quantity in one time. The machine can sieve up to 5 kg of flour at one time. Second is the size. The dimension for the machine is 700 x 600 x 350 and the unit is in millimeter. Third, the machine is a semi-automatic sieve. Fourth, the machine is a fast sieve because it can sieve 15 minutes per 1 kg of flour. Fifth, the noise produced from the machine is 60 dB. And the last is total mass for the machine is 15 kg. Next is the bill of material. First is the machine cap. As you can see, this is the machine cap and the 2D drawing of the machine cap. There are two items on the machine cap, which is the first one is a fillet head screw and the second one is a cap holder. And the height for this machine cap is 100 and the height and the diameter is the 600. And the material that we use is stainless steel. For the level 1 floor input, as you can see, this is the floor input and the 2D drawing. The height for this level is 250 and the diameter is 600, and the material is also a stainless steel. The level 2 is the swivel. This is the sieve and the 2D drawing of the sieve. There are 5 items on the 2D drawing for this level. The first one is the mesh, second is the component, third is year 1, fourth is year 2, and lastly is the sieve. The material that we use is also stainless steel. The height for this level is 100 and the diameter is 600. And for the level 3 is the floor output. This is the floor output and the 2D drawing of the floor output. The height for this level is 150 and the diameter is also 600, and the material that we use is also stainless steel. Next is level 4, base generator with rod. This is the base generator with rod and the 2D drawing. As you can see, there are 5 items on the 2D drawing of the base generator with rod. The first one is the base generator, second is the cap generator, third is the steel hexagon head screw, fourth is the steel hexagon screw, and the fifth is the side rod. And this is the side rod. The height for the side rod is 600, and this is the full assemble for the machine and the 2D drawing of the full assemble drawing. As you can see, there are 9 items on the 2D drawing. And lastly, the external part of the machine. The first one is a auto vibrating motor. This is very important because it function as a main part to our machine. The function is to run our machine. And for the second one is the hot air blower. Hot air blower is used when we wash the machine and the machine get so wet, and then we blow it to machine so that the floor can be prevent from sticking to the machine.
We have put 3 critical design to be analysed. In engineering, a factor of safety, also known as safety factor, expresses how much stronger a system is than it needs to be for an internal load. Safety factors are often calculated using detailed analysis because comprehensive testing is impractical on many projects, such as bridges and buildings, but the structure's ability to carry a load must be determined to a reasonable accuracy. For ductile materials, it is often required that the factors of safety be checked against both yield and ultimate strength. The yield calculation will determine the safety factor until the part start to deform plastically. The ultimate calculation will determine the safety factor until failure. On brittle materials, these failures are often so close as to be indistinguishable, so is it usually acceptable to only calculate the ultimate safety factor. Appropriate design factors are based on several considerations such as the accuracy of prediction on the imposed load strength, weight estimates, and the environmental effects to which the product will be exposed in service, the consequence of engineering failure, and the cost of over-engineering the component to achieve the factor of safety. For example, components whose failure could result in substantial financial loss, serious injury, or death may use a safety of 4 or higher. Non-critical components generally might have a design factor of 2. This analysis, failure mode, and effect analysis and other tools are commonly used. Design factor for specific application are often mandated by law, policy, or industrial standard.
Okay, I'm going to present about the digital prototype. Okay, what is digital prototype? Digital prototype is a combination of the conceptual design, engineering, manufacturing, and the marketing department before the complete product is built. This digital prototype they provide an analysis of the product by using CAD software such as Fusion to run the analysis such as safety factor, stress, and the strain of the product design to ensure how the product work. Okay, this analysis is very important because this analysis give the feedback of the product, whether the product is suitable to be built or not. This digital prototype also can convince the customer about the product that we are going to build. Okay, as you can see from the video, the analysis was run with 100 Newton, which is equivalent to 10.2 kilogram. Okay, the safety factor of this product is 15. From the previous video, okay, this analysis is the stress of the product. Okay, the force have been placed on the base of the generator. Okay, the force used is 100 Newton because the upper part plus with the 5 kg of flour to be inserted into the sieve. Okay, as you can see, the product have a stress of 3.983, power of 10 negative 4. This product can withstand the force of the floor and the upper part. Okay, this is the all assembled part, which is from the top level and until the base of the generator.
What we can conclude, this project can help for people to see more floor than usual. It is also can help the quality of the floor is same and more efficient with the using of mechanical system. Our objective is achieved due to the products that we made. That's all from us. Thank you.